Good morning, everyone, and welcome to today's edition of Grade 4 News, brought to you by Pick Collage. I'm your host, Mr. D'Souza. Now, today we'll be looking at doing some spelling for literacy, then we'll move over to maths and do some division and more decimal and fractions, and then we'll be concluding today by doing lesson 2 of forces. So let's get right to it. Alright, now time for some spelling. Who here knows what homophones are? Anybody? Well, homophones are words that are pronounced the same or very similarly, but they have different meanings. Can you think of a homophone? Well, if you said no, well, that's a homophone already, because no can mean no as in no thanks, but it can also mean no as in I know something. Let's take a look at some examples. Okay. Alright, here we go. My shoelaces were tied in a double knot. Which one would be the correct spelling? Let's have a look. Not with the K, with the silent K, okay? Because the other knot means no, do not do that, okay? Because that one means we will tie up the knot, okay? Cool, let's keep going. All classes went swimming except year 1. Sounds a bit tricky. Except which one? Write down your answer. If you wrote that one, then you are correct. Because the other except with the A means when you accept something, when you take something, okay? Whereas except means when something is excluded, okay? Let's keep going. All right. The bad something means that we may have to cancel sports day. The bad weather, but which weather is it? Do you know the answer? If you wrote that weather, then you are correct. So that weather talks about, sun, rain, hail, that type of weather. Whereas the other weather, it's like saying, I'm going to do this whether or not, or whether this video will be helpful or not. Okay, let's keep going. The something swooped down low over the airport during the air show. What could that be? Plane or plane? Which one is it? Write down your answer. If you spelled plane, P-L-A-N-E, you are correct. Because the other plane means when something is ordinary, plain. That white piece of paper is very plain. Yeah. Okay, let's keep going. Each child ate something of fruit at break time. Piece or piece? What do you think? Well, if you wrote peace with an I, then you are correct. The other peace means peace man, peace be with you. Alright. Now we come to, you should have a sheet in your packs that looks like this. These are your spelling words for the week, okay? I want you guys to write them down, not once, not twice, but 3 times. By that time, you will be an expert at these words and how to spell them. And just think about their meanings as well, okay? If you need help, ask your parents or Google if you forgot Google their definitions if you forgot. Otherwise, these are your spelling words for this week, okay? Remember them and memorize them because we will have a test on Friday. Alright, now time for some maths. So today we're looking at tense as decimal fractions. Now the best way to show the relationship between fractions and decimals is to demonstrate it using a number line. So if you look over here, here's one I prepared earlier. Okay. So 1 over 10 is the same as 0.1. So if you got a calculator and did 1 divided by 10, you would get 0.1. Then 2 over 10 would be 0.2. 3 over 10 would be 0.3. And so on and so on. Okay? 7, 0.8, 0.9, and then you get 1 or 1.0 if you want to be technical. Alright, so that's one way of demonstrating the relationship between decimals and fractions, okay? Now let's have a look at another example. Let's have a look at another number line. Now this one goes from 0 to 2.0, or 2. Don't get confused, that is not 20, okay? Even though there's 20 lines. Decimals and fractions are smaller than whole numbers, okay? They're bits and pieces of whole numbers. Now, if we were going to, if I asked you to place 0.8 on the number line, where would it go? Well, we know 0.5 is there, so it'll be 0.6, 0.7, 0.8, right there, okay? Easy, right? Let's do one more example. If I asked you to place 1.6, where would that go? Let's see, well 1.5 is over here. So we know that 1.6 will be right next to it. Easy, right? Cool. Now that you have these skills, you should be able to complete the rest of the questions all by yourself. Good luck. You can do it. Alright, now time for some integrated studies. Let's continue on with our topic of forces, okay? So let's have a quick recap of yesterday. Newton's laws of motion. First of all, who was Isaac Newton? Does anyone know? Well, if you've heard of that story, he was a famous scientist back in the days, and he was trying to figure out why things move. And he was sitting under an apple tree one day, and an apple actually fell and hit him on the head. And that's how he developed these laws of motion. Okay, let's have a look at the first one, inertia. So Newton's first law states that objects in motion tend to stay in motion, and objects at rest tend to stay at rest unless acted upon by an unbalanced force or an outside force. So let's take a look at the first example. So an object in motion, okay? So say, going back to yesterday's example, pretend you're in the car or your parents are driving, you're sitting in the back seat, then suddenly they get to a red light and they stop really hard, they brake really hard, and what does your body tend to do? You tend to go forward, but your seatbelt keeps you in, okay? See, that is inertia. That force pushing you forward as the car stops, that's inertia, okay? Another example, so an object at rest tends to stay at rest unless acted upon an outside force. So say if you're just sitting down on a chair, just watching some Netflix, you know, you're at rest, okay? You're not gonna move. But then your little brother or sister comes up from behind and pushes you over. That's Newton's first law. That's also a form of inertia, okay? Now, Newton's second law, force equals mass times acceleration. What does that mean? Let me demonstrate that. Whoop, have a look at this balloon. It doesn't take much force for it to fly up into the air, yeah? Whoop. Not much force at all, because its mass, the stuff that it's made out with, is mostly air, which is super light, okay? Now if this balloon transformed into a solid concrete or rock, it would take me a lot more force to be able to lift it up into the air, yeah, if it was solid rock or concrete, okay? And yeah, so force is the force that I'm applying to push it, mass is the stuff that it's made out of, and acceleration is the movement or the speed that it is projected, okay? And finally, every action has an equal or opposite reaction, okay? An example of this is if I were to, I don't know, push against a wall. It's hard to imagine, but that wall, so I'm pushing force forward, okay? But that wall, it's hard to imagine but that wall is actually pushing back, okay? Okay, so every action has an equal and opposite reaction. Okay, so have a look at your planner for today. I think the activity today is to create your own poster illustrating these 3 laws. Draw some examples. Try to come up with your own. If you struggle to come up with your own examples, just draw something that you saw in one of the videos or this video. Okay. Enjoy. Alright, that's about it for today's episode of Grade 4 News. Before we go, let's quickly switch over to Mr. Gali for today's weather report. Take it away, Mr. Gali.
It's gonna rain.
Thank you, Mr. Gali, for that very detailed weather report. Well, kids, that concludes another episode of Grade 4 News. Don't forget to upload all your work on Seesaw, and I will mark it as soon as possible. Till then, take care of yourselves and each other. God bless.